So our topic for today is changing standard form to vertex form. And to remind everyone, standard form is y equals ax squared plus bx plus c. Vertex form is y equals a parentheses x minus h parentheses squared plus k, where h and k are your coordinates for the vertex of your parabola. A is the one that determines, on the vertex form, A is the one that determines whether it opens up or down. If it's positive, it opens up. If it's negative, it opens down. If this is a number that is greater than 1, then you're doing a vertical stretch, which means that your graph is going to be more narrow. When this is a small number, then that means that you're vertically compressing, which means that your graph becomes wider. So let's go and work on this first example. Y equals x squared plus 16x plus 71. So what I taught you was you can actually put this on the other side. Make sure that this is a 0 first. The reason why this is a y because we are dealing with equations this time. So this has to be changed to 0 if you wanted to use the process of completing the square that I taught you a couple days back. So this is going to be x squared plus 16x plus 71, which negative 71 will stay here. That will be equal to x squared plus 16x. And once again, I just wanted to emphasize that the coefficient of x squared has to be a 1. And it is already a 1, so we didn't do anything. Now we go to the second step, which is to put your c on the other side. We did that. The third step is to identify your b, divide it by 2, and square it. So your b is 16, divide by 2 is 8. 8 squared is 64. So what we're going to do is we're going to add a 64 on both sides. So that's adding a 64. It's the same. So now this is going to become a negative 7. And this now is a perfect square. So you will have x, get the sign of the middle number, get the square root of 64, which is 8, and square it. Now, I want you to look back at your vertex form equation. This side right here and this side are together. So this has to go back. So therefore, this now is going to look like y again. Let's go back to y because it's an equation. So we'll now have x plus 8 squared plus 7. And there you go. Your vertex, this is now the vertex form of your parabola. And this is the standard form. These two are the same. Now, let's identify the vertex given this one. The vertex has now the coordinates of negative 8, because I hope you remember long time ago we said that it's always the opposite inside. So this is negative 8, comma, and that stays as positive 7. So those are the coordinates of your vertex. So this is our example number 2. Our first step is to make sure that the coefficient of x squared is a 1. So what we're going to do is to divide them all by 2. However, another way of showing division is by factoring out. So again, let's set that to 0 because we're doing the completing the square. And this now has to be like this. Now, step number 2 is take your C and put it on the other side. However, if I put this on the other side, please take note, this is not 85. This is 85 times 2, because when you go back, it's 85 times 2, or that is 170. So putting the positive 170 on the other side, that's negative 170. This time I'm leaving a space. So, but it's the same thing as what we did a while ago. I just wanted to show you a different way. So this now would look like this. I'm leaving a space, it's because of the next process, which is get the b, divide it by 2, and square it, and add it to both sides. So now our b is 18, divided by 2 is a 9. 9 squared is 81. We're going to add 81 on both sides, so that is plus 81. I apologize for that. I said we're going to add 81 on both sides. That's not really an 81 because it's 81 times 2. So really what I added is 162. Therefore, when I go to the other side, I make sure I'm aware of that and I add a 162, thereby making this become negative 8. And this now is a complete square. So you have 2x, copy the sign of the middle number, get the square root of 81, which is a 9, square that, and put this back on the other side. So that now turns to a y, 2x plus 9 squared plus 8. This now is our h and k. So our vertex has the coordinates negative 9 and positive 8. After getting the vertex, I added another information, which is now the axis of symmetry. So just roughly graphing how this graph looks like. Well, first of all, I know that it opens upward because your A is positive. And I know that your graph is narrow than the standard form because, or the parent function, this is narrower because it's being vertically stretched. And the way to know that is when your A is greater than positive 1. So now, this is how roughly my graph looks like. And the way to get the axis of symmetry is, of course, from the vertex, you have negative 9, 8. And the axis of symmetry is the line that is a vertical line that crosses the vertex. So your equation is going to become x equals negative 9. Okay, example number 3. This is a different kind of given because the y is together with all these terms. So y has to be alone. So I'm going to leave the y there and put all of them to the other side. So that's a negative 6x squared minus 12x minus 13. And then I need to make sure that that is going to be a 1 by factoring it out. Now that will look like negative 6. Inside is x squared. This now is a negative, so if I take out negative 6 from it, it's going to become a positive 2x. The way to check is go back and multiply. It should be the same thing as the given, which is negative 12x. Now, this one, if I take out negative 6 from here, that means also that I'm dividing this by negative 6. If I divide this by negative 6, then I will have a fraction. And I don't want to do that if at all possible. So what I'm going to do is I'm going to just move this to the other side. Now, why is that the same? I hope that you still remember your example number 2. Watch and see. When we factored out the 2 from the 170, it became an 85. But when we moved it to the other side, we had to go back and put the 2 back there, which will turn out to be, again, positive 170. But it turns to negative because it went to the other side. Therefore, this 13 over here, I can just put it on the other side. So now, by the way, this becomes a 0, and I want to put that there first. This is the one that you factored out to 6. So I'm closing the parentheses there. So now this goes to the other side. And it becomes positive. And I'm now leaving a space because I will now start the process of getting the b, dividing it by 2, squaring it. So the b is a 2. Divide by 2 is a 1. 1 squared, or 1 times 1 is a 1, which I will add on both sides. However, again, what I added here may look like a 1. It really is not, because I have a negative 6 outside. Therefore, what I really added is a negative 6. Therefore, I have to add here a negative 6 by doing this. That's the same, guys. That's the same. If I add a negative 6 there, that's the same. So I will now have here a positive 7. This now is a perfect square, so negative 6 parentheses x, copy the sign up the middle, get the square root of 1, which is 1, square it. I need to move back my 7 so that I can have the vertex form. So now put the y equals negative 6 x plus 1 squared minus 7. Therefore, my vertex is the opposite of that, which is negative 1, and that, which is my negative 7. And my axis of symmetry is always x equals whatever this is. So negative 1. Okay, example number 4, y plus 6 equals parentheses x plus 3 squared. The only step we will have here is y on the other side. Move this to the other side. So we'll have x plus 3 squared minus 6. And that is it already. This is already in the form of y equals a x minus h squared minus k. I'm sorry, plus k. So our vertex is negative 3 comma negative 6, and our axis of symmetry is x equals negative 3. Example number 5, 1/2 parentheses y plus 4 parentheses equals parentheses x minus 7 close squared. Now, this is a wonderful site right here because it's partly looking like the vertex form already. All we need to do is to settle this side and make sure that it's y that is alone. Okay, to get the y to become alone, the first thing I will remove is the 1/2, and to get rid of that, I will multiply this by 2. Whatever I do on this side, I do on this side. Now, I will rewrite this. This now is gone. I will just have y plus 4. I will put this 2 in the front, making it look like this. Okay, see that? That's your A. And move this to the other side. And you're done. Equals 2x minus 7 squared minus 4. Your vertex is positive 7 comma negative 4. And your axis of symmetry is x equals positive 7. Our next example and the final one is y equals x squared plus 4x. So again, let's make that 0 equals x squared plus 4x. This is plus 0 really because there's nothing there. So now, this is a 1 already. Let's pretend that we put that on the other side. So what's 0 minus 0 is really just 0 equals x squared plus 4x. And we leave that space because we're now getting our b divided by 2 squared equals 4 divided by 2 is 2 squared. What's 2 times 2? It is 4. That's what we're going to add on both sides. So this now would look like 0 plus 4. This is x squared plus 4x plus 4. And this is now a perfect square. X plus 2 squared. I will just go ahead and put this on the other side, making it negative 4, and go back to y. Therefore, our vertex is the opposite of that, which is negative 2. This, which is negative 4. And our axis of symmetry is x equals that, negative 2.